Okay, so y equals mx plus b is your new life uh, once you hit the algebra world. So y equals mx plus b is simply an easier general way to write a proportional relationship or a linear relationship than, say, a table or a graph. So this, let's say we have, some data, and um, we'll make it, there you go. Now, if I wanted to know what x or what y was going to be when x is 32, I could count, right? Because I've got this plus 1, plus 1, plus 1, and this is plus 2, plus 2, plus 2. So I could just write it out, right? Until I got to 32, and then I would have my y value. But that would take a really, really long time. Same thing if I have a graph. So let's say I have a graph, which, by the way, I just want to point out that I'm getting a lot better at drawing sketches of graphs. I mean, those are some pretty awesome straight lines. So just saying. So that's, oh, no, it's not. There we go. X and Y. So, let's say we have this line. It's proportional. It goes through here. And we have these coordinates. They are on the line. But let's say we want the same thing. So this is 1, 2, 3, 4, 5. Let's say I want to know where the coordinate's going to be when this line hits, I don't know, 100. Well, that would take up a lot of paper. So instead of that, we have the equation form. So instead of having to take a lot of time or a lot of space to figure out values that are really large numbers, we have the equation. And the equation we use is that slope-intercept equation. Y equals mx plus b. And this is all that it's saying. All that this is saying is y equals mx. Nope, I'm going to start that over. Hang on. So all this is saying is that for any coordinate, y and x, which again you can get from a graph or you can get from a table, for any coordinate y or x, the way to get from the coordinate can be found, like to move from one coordinate to the next or to find the value of the coordinate, you are going to multiply x by the slope and add or subtract, depending. So it can be plus or minus the y-intercept. Okay, so all this is saying is, look, to get my y value, I just need to know what's happening in between here. So to find the slope, so this is the key point, well, one of many, I suppose, to find the slope, you go this way, right? Or the other way, depending on what your values are. But that's to find the slope. To use the slope to write the equation, like to apply that, you actually go this way. Okay? So you'll notice here that my change in y is 2 and my change in x is 1. Well, when you look at it this way, to go from x to y, you're multiplying by 2. 1 times 2, 2 times 2, 3 times 2. Okay, and that way I can say, oh, well, if I'm just multiplying everything by 2, then that means if I do 32 times 2, then my y is just going to equal 64. Well, that is the equation. That's the equation portion that says, look, this, to get from x to y, I have to multiply by my m, which, oops, I don't know why I wrote that over here. To get from x to y, I have to multiply x by my m value, which is 2, or 2 over 1. That is a way easier way to do it than counting 4, 5, 6, 7, all the way up to 32. Same thing here. Instead of going all the way up to when x is 100, we can simply say, look, okay, to get from this point to this point, I'm going up and over 1, up and over 1, up and over 1-ish. So here, my slope is 1, which means that if I want to know what the coordinate's going to be when x is 100, all I have to do is multiply my x coordinate by 1, which that's an understood one. We don't actually need to write that. So in this case, it's actually y equals x. That graph's not to scale, so sort of ignore that. But that's what you would do here. Okay? This is a much faster way to write this relationship so that you can find the coordinate at any given point on the line. Same thing here. Way easier to find a value if you have the equation. The b value is simply where your line starts. So proportional relationships always start at 0. This coordinate right here, this 0, 0, that's proportional relationship. However, you have linear relationships. There's a constant rate of change that aren't proportional, and that's because they have a different starting point. So maybe they start here, and it's still a line. You're still moving the same amount for rise over run. You're still doing that. You'll go from here to here, from here to here, from here to here. It's still a linear relationship, but you have a different starting point, and that's your b. Your b is your starting point, how far away from 0. So what this would be is you would have a positive b, because maybe this is, 1, 2, 3. Maybe that's 3 units away from 0, positive units. So you'd have y equals whatever the m is, x plus 3. If you had a line that had a starting point below 0, maybe it goes this way, I don't know, could go this way, either way. And let's say this is 1, 2, this would be minus 2. So let's say this is 3, so we'd have something plus 3. Here we'd have something minus 2. So all of this value is, and I don't think that it does a very good job explaining this, all this value is how close you're starting to that 0 point. If you're starting on that, if your line goes through that, if that's a starting point, then your equation doesn't have to add or subtract anything because it's starting at the 0, 0. So when you're going among these forms, when you're looking at a graph and it says, what's the slope, or which graph